Boom. Hello and welcome back to Calculus 1, section 4.6, mean value theorem. Mean as, you know, median value, not evil. So, let's understand the concept first, and then write down the theorem. My favorite part when I get to draw the road. I get to draw a bush over here, another one over here. It's a shrubbery or whatever. I get to draw a car over here. And get to draw another car over here. We know what these cars are, right? Yeah. What happened? Ah. So now this is the standard setup, right? You have a road which has a speed limit on it, and then you have these two traps now. Now this is what happens. You're driving on this road, going forward, and both of these cars are measuring speed. Now, you obviously invested $400 in a radar detector, right? And you pass, and you detect the signal coming out of the cop car, so you slow down to the speed limit, and you pass through the first trap at 55 miles per hour. You're not pulled over, you're not ticketed, no issues, you move on. And then you drive these 5 miles in between at whatever speed you want, and then your radar detector goes off again. As you are to go to the second one, you slow down, you pass 55 miles per hour through the second one, and you go. You never got pulled over, never received any tickets, didn't talk to any of the two cops, all cool, move on. A few days later, ticket arrives in the mail. What happened? Well, the issue is that you passed through the first gate at 1:04 p.m. but to the first trap, and then you pass through the second trap at 1.8. So they didn't just record your speed as you were passing by, they also recorded a time, and then they compared the times. And I think that you see where the debacle comes in now. See, the problem is that you covered, right, the speed is the distance over time, overall distance you covered, which is 5 miles, by 4 minutes. Now those 4 minutes will be converted into hours, so I'm going to call it 4/60 for hours. And when you calculate that, you get 300/4, which is 300/4 is 0.8. So your average speed for that trip between the two squad cars, clocked at 75 miles per hour and a speed limit that was 55, and you passed 55 through both traps. Your ticket arrived, obviously, at 75 miles per hour. Huh? I was never pulled over. I never talked to the cop. I never took the ticket. It just arrived in the mail. The hell? Well, medium value theorem, the hell, right? What medium value theorem states is that if the function is continuous and differentiable, which is, you are driving on a continuous road, you didn't get to teleport or anything like that. So if the function is continuous and differentiable, at least one point, average speed and instantaneous, well, average value and instantaneous value, which is the derivative value, are the same. When you get pulled over while driving, you get pulled over for instantaneous speed, which is the instantaneous speed that your speedometer is reading at the moment you were measured. So, when the cop measures someone, right, that's done in a split second, and that's exactly what the speedometer was doing. Now, that speedometer that you have is the instantaneous velocity, because you know it changes instantly as soon as you push either gas or brake pedals, because those control, right, deceleration or acceleration, so they both change speed. So, instantaneous velocity, which is your speed, is the one that your speedometer shows at all times. And you get ticketed for that one. When you pass through both of these, they were at 55, which was exactly the speed limit, no harm done. However, the average one over here shows that it's 75, and a theorem says that if your average one is 75, then your instantaneous one, which is the speedometer, had to be at least once 75. At least once. And because it's a mathematical theorem that is proven, you can't beat it in court. Does this exist? Yeah, it does. Is it piloted? Yep. Easy pass. Your account goes to first gate, and if you arrive sooner than 13 minutes to the next gate, mail the ticket automatically. It doesn't involve humans at all. Your account passes to the first one, your account passes to the second one. It just compares the time. That's in a program. And a program prints the tickets and sends it. Yeah. So you can drive 105 and then stay parked for 6 minutes in front of the next easy pass for 4 minutes. It's okay. And then pass it right. You're going to fool the gate, right? You're definitely going to fool the system. If you go 105 and then stay parked 4 minutes, good to go, right? No issue. But if you pass sooner than those 13 minutes that are actually, right, minimum amount of time that should take for you to cover whatever distance it is. Well, obviously if it's 13 miles and 60 miles per hour, then it has to be 13 minutes because you drive minutes per mile. Mile per minute. So, yeah, that's that. Now, I already said that the mean value theorem states that these things have to be the same. So now we just write a theorem. So if f of x is continuous plus differentiable on a to b, then there is at least one x equals c where average f of b minus f of a over b minus a is equal to f prime at c. C is always between a and b. Guys, on the left you have the slope of the secant line, on the right you have the slope of the tangent line, and if you say that two slopes are the same, that means that the lines are parallel. Does that make sense on the picture, on the graph of f of x? And the answer is hell yes. So you have this, you have this, and you have this. All right, so now that I set everything up, I can come up with my A's and B's. And my C. Same slopes. So mathematically, this is what's happening. You see that now if you think about this, we can talk about our car case in time and let me just see what would be the best way to. So, I want to see how to put the graph so it's clear. By the way, you all see that this is the slope of the secant line, right? It's y2 minus y1 over x2 minus x1. It's the algebra written through pre-calculus function. And on the other side, you have the slope written as a derivative, which is instantaneous. So you have the average world and instantaneous world, and you have the word equal, the symbol equal in between. So that's why you can get a ticket. Now, in time, what we show, again, is that at A point in time and B point in time, you had the same speed, and in between, let's say you went crazy like that. So you pass the first cop car and you say, it's not going to be any more, because generally they don't go and sit a mile apart. So from 55, you really went fast and then slowed down, and then the radar detector went off, and then you slowed down to the 55. You see how the average of these 2 points is the slope that connects these 2 points. In this case, that slope is equal to 0, right? But it's at the 55 level. And look at this one. That one is also m equal to 0. And that's that one, value C, which gave us 75 miles per hour. So it's two slopes that are the same slope because the lines are parallel. You see over here I have them slanted, over here I have them parallel. You're 55 on the first cop at time equals 8. This is 1.04. And then 1.08 4 minutes later, second cop car, right, you're still going 55 miles per hour. But when you do the slope of the tangent line between those two, right, if I do a graph this way, you get that the change in speed is 0 between these two because you went 55 and you're 55. Obviously the change is 0. But when you consider the function that connected it, you went 55 and then the next second you went 65, 75, 85, 95, 100, right? And then reduce it down to 60 and again 55. Wherever that other max happened, that one is also going to have the horizontal. Now, it's not always guaranteed that it's going to pick up a max. It's just going to pick up values. So they can't claim that you went max, right? Obviously, if the average is 75, it's like on the exam, right? What do we have on exam today? Lowest grade was 18. Highest grade, 105. class average, right? It wasn't 18 or 105. You don't get to pick up min and max by this procedure. You get the guarantee that these are somewhere equal, right? Somewhere on the interval, because the slopes are parallel. And technically, that's all you pick up. I'll do one more example of this, because it's literally just, I believe they have very few examples, maybe 5, and that's it. Generally, I do one with numbers and one word problem. So let's take a look at where's the mean value theorem. So problem 20 says find C if the function that it's given is ln 2x and the interval we are considering is 1 to e. Well, in order for this to work, you have to make sure that the function is continuous and differentiable, which it is. You can find derivative everywhere, and it's continuous. So we find the derivative first, which is 2x to just 1 over x. And now we write the formula. So f of b minus f of a over b minus a needs to be equal to f prime of c. So now you have your f of x, and you need to plug in b and a. So that's going to be ln of 2e minus ln of 2 times 1. So that's plugging in b, which is e, and a, which is 1, divided by e minus 1. Needs to be equal to the derivative computed at this unknown value c, so it's 1 over c. Guys, note that f prime of x is 1 over x. F prime of c is 1 over c because you plug in c for x. And now compute. So ln 2 times e, if you know your logs, you know that that's ln 2 plus ln e minus ln 2 over e minus 1 is equal to 1 over c. These guys drop. Ln e is 1. So 1 over e minus 1 is 1 over c. Cross multiply. C is equal to e minus 1. Done. So you can say at x equals e minus 1, we have the average equal instantaneous. So they have the same value. The value of the derivative and the value of the average is the same. That's the numerical example. And I just need to find, where's the eraser problem? $35. There it is. It says running pace. Explain why, if a runner completes 6.2 miles race in 32 minutes, he must have running at exactly 11 miles per hour twice. So explain why in a 6.2 mile race, which is completed in 32 minutes, the runner had to run at 11 miles per hour exactly, at least twice. Well, this part is for the average. You have that the average speed is going to be 6.2 divided by, now we need this in minutes, so 32 over 60. you will get the average speed. So 60 times 6.2, so that's like 62 times 60, is 3,720 divided by 32. Oh, okay. It was 11.6. So the average speed is 11.63 miles per hour. So that's the average. Now we have that the average is equal to instantaneous, right? So we know that the runner hit 11.63 at least once. But they ask, why is it at least 11, at least twice? Well, think about it, right? When you start running at the zero velocity. And then you run, and you get tired, and then you stop. And your velocity is zero again. So you start at the zero velocity, and you end at the zero velocity. You can see that at least over here, the top with the zero slope, you had 11.63, which means that 11 is somewhere below, which cuts it here and here. So at least at these two times, right? At least at those two times, you had 11, because you were running faster than 11. If you start at 0, and at any point in time you run more than 11, that means that you have to accelerate through 11 to get to 11.63, and then you didn't continue running forever. You stopped, which means that you decelerated for 11.63 to 11.20 at one point. Now, maybe you did that 15 times. I don't know. But at least you did it twice, because you started from velocity 0, you ended with velocity 0, and you went through 11.63. So your graph might have looked like this. Whee, right? And stop where all of these are 11.63s and 12s and 13s and whatever else. See how many times you hit 11? Every time you go, right, you have to hit 11, right? But it's guaranteed to have at least 2, because you start running from 0, and right, and that's it. So that's the mean value theorem. The idea is to know that the average speed and the instantaneous speed are the same, at least at one point, and then after that, rest. Now, before you